remember this pretty well. Okay, so today we're going to talk about what's called deductive reasoning, okay? And it's just a way of reasoning logically from given statements or facts to help you get to a conclusion. So it's basically, here's all your information. How can you use this information to come to a conclusion? So that logic puzzle that I gave you guys on Monday, that was very hard. You have to use deductive reasoning to do that logic puzzle, whether you knew it or not. So like on that logic puzzle, if you said, okay, well, I don't even remember what the names of the streets were. I know they were. If Rose's house is red, and you know the red house, or the red block, has 45 people on it, well, you can conclude that the Rose house has 45 people on it, right? Hopefully, you kind of made those connections. That's using deductive reasoning. So there's two laws that we're going to talk about today that we are going to see a lot, especially as we start getting into our proofs. So the first one is called the law of detachment. And this one's pretty simple, and it's kind of things that we already know. But I think the hardest part is not trying to misuse the law of detachment. So the law of detachment says, if the hypothesis of a true conditional is true, then the conclusion is true. Which we know, that's how we check if the conditional is true. Every time the hypothesis is true, the conclusion has to be true. So if you have a specific scenario, okay, and you know the hypothesis is true, you can then go ahead and say, okay, well, here's my conclusion, okay? So symbols, if P, then Q is true, and P is true, then Q has to be true. So my example, sometimes it's easier whenever we look at actual examples with words. If you throw your phone from a 3-story building, it will break. Okay? Well, Allie threw her phone from a 3-story building. Well, we know that if it's a true conditional, if you throw your phone from a 3-story building, it will break. Well, if Allie threw her phone from a 3-story building, it broke. Okay? Yes. Huh? We're going to assume that this is, just a regular old phone. So, yeah. Okay? All right. So that's the law of detachment. Pretty simple. Now, I think what's difficult about this is you can't confuse the conditional with the converse. I know that's what we were doing yesterday, flipping things around. And even if you think you're like, well, I'm pretty sure like that's a biconditional, if you could go both ways, that's not what we're doing today, okay? So if you're going to use the law of detachment, the given information, so Allie threw her phone from a 3-story building, that has to be the hypothesis. So if I had instead given you the information, Allie's phone broke, well, maybe she threw it from a 3-story building, or maybe she dropped it in the toilet. I mean, I don't know, right? You don't know. You have to be given something that's going to prove the hypothesis true. If the hypothesis is true, we know the conclusion is true. Okay, does that make sense? Okay. The other one is called the law of syllogism. Okay? So the law of syllogism, that example where I said if Rose block is red and the red block has 44 people, that's the law of syllogism. Okay? The law of syllogism lets you take two separate statements, two separate conditionals, and kind of in a way combine them into one. Not like a biconditional, but what it does, it says, okay, if you say a conclusion from two true conditionals, okay, allows you to state a conclusion from two true conditionals when the conclusion of one statement is the hypothesis of the other, okay? Probably the easiest way, I mean, if you look at the symbols, if P then Q is true, and then Q then R is true, then you can connect P to R. Okay? I don't know why P's and Q's, I don't like P's and Q's. So if A then B, and B then C, then you can just jump from A to C. Okay, you don't need that B in there. Okay, now you have to pay special attention when you're trying to do the law of syllogism. Okay, for the law of syllogism, you have to have the hypothesis and then the conclusion. That conclusion has to be the hypothesis for the next statement. Okay, so it should match in the middle. Okay, and then you have your final conclusion if you want to connect the first statement with the last statement. So, if you throw your phone from a 3-story building, it will break. If your phone breaks, you have to buy a new one. So see how if you throw your phone from the 3-story building, it will break. That's the conclusion. That conclusion is now the hypothesis. If your phone breaks, and we have our next conclusion, you have to buy a new one. The part that's not necessary here, what we can connect here is we can say, well, if you throw your phone from a 3-story building, then you will have to buy a new phone. You don't need the part that it will break, okay? Because we can connect those two together, okay? Does that make sense? Okay. We are going to do all of our notes in the same setting. I didn't write anything on this. So maybe we'll just wait to blue until we finish up the other side of the notes because we're going to have to do that in as well. Okay, so let's put some of these to use here. Okay, if possible, we're going to use the law of detachment to make a conclusion. Just basically, okay, here's the information I'm given. Well, I can conclude with this. Okay. Now, sometimes we won't be able to make a conclusion. If that's the case, then we're going to go ahead and tell why. So, number one, if it's raining outside, then there are clouds in the sky. It's my hypothesis. It's raining outside. Conclusion, there are clouds in the sky. The given, okay, we're going to be hearing that word a lot starting on Tuesday. The given says it's raining outside. Now, if you're going to use the law of detachment, your given has to prove that the hypothesis is true, okay? Even if you think, well, you can flip out those clouds in the sky, it's raining. If you can, it doesn't matter. That's not the statement that they gave me, okay? So the given has to prove that this hypothesis is true. So my hypothesis was it's raining outside. Does it's raining outside prove that it's raining outside? Yeah. So this is true, which means there are clouds in the sky. There are clouds in the sky. That's the conclusion that you can make. Okay, number two, this is where you have to be really careful. So number two says, if a figure is a square, then its sides have equal lengths. Figure ABCD has sides of equal lengths. Remember, guys, even if you think this is reversible, it doesn't matter, okay? What they're given to me, and this actually wouldn't be true the other direction, not all of the time, the given statement has to prove that my hypothesis is true. What's the hypothesis here? A figure is a square, okay? Does ABCD that has sides of equal length prove that it's a square? No. Oh, it's like a rhombus has sides of equal lengths, okay? And it's not a square. Okay, so no, you can't make a conclusion from this. So how you could tell why is you could say, we don't know the hypothesis is true. We don't know the hypothesis is true. Using the given, you have to be able to say, okay, the first part's true, which means the second part's true. That given statement needs to show you that. Okay, so number three, if Malcolm scores at least an 85% on his final exam, then he will earn an A for the term. Malcolm scores a 90% on his final exam. Now, my given that he scored a 90% on his final has to prove that my hypothesis is true if I'm going to make a conclusion. What's my hypothesis here? Yeah, he's got to score at least an 85 on his final. So my given information, if he scores a 90%, is my hypothesis true? Yeah. So I can conclude if he scores a 90% on his final, then what? He will earn an A for the term. He will earn an A. Okay, questions on the law of detachment. Okay, the law of syllogism. Okay, guys, remember, the middle statements have to be the same, okay? You have to go from hypothesis to conclusion, and then that conclusion has to be your next hypothesis. It should be like A to B, B to C. Those B's have to be the same statement. Okay, not, worded exactly the same, but they need to be saying the same thing. So number 4 says, if a number is divisible by 12, then it is divisible by 6. If a number is divisible by 6, then it is divisible by 3. So what you're checking, okay, the first hypothesis leads to a conclusion. What's the conclusion of that first conditional? What's the conclusion for that first conditional? It's divisible by 6. That should be the hypothesis of the next conditional, is it? Yeah, then it's divisible by 6, okay? So what you can do is you can kind of take out that middle part. I don't need to know that it's divisible by 6, number's divisible by 6. I can just take that first statement by 12 if a number is divisible by 12, then I can cut that stuff out because it connects those two. I can say then it is divisible by 3. Okay, but the big thing, those middle statements have to be the same thing. The conclusion of one has to be the hypothesis of the other. Okay? So number 5 says, if a figure is a square, then the figure is a parallelogram. If the figure is a rectangle, then the figure is a parallelogram. Okay, so remember, the conclusion of one has to be the hypothesis of the other. Is that true for this one? I do see a statement that's the same, right? I see that the figure's a parallelogram, the figure's a parallelogram. But what is the figures of parallelogram in both of my statements? It's the conclusion for both. Okay? If it's the conclusion for both, I can't connect these two. Okay? I can't connect them, and I guess my explanation here would be the conclusion is the same for both. The conclusion is the same for both. It would have to say, if a figure is a square, then the figure is a parallelogram. If the figure is a parallelogram, then, and then something. See what you would have to see? Okay. And then the last one here for this one, if a whole number ends in 0, then it is divisible by 10. If a whole number is divisible by 10, then it is divisible by 5. Okay, so the conclusion of the first is divisible by 10. Should be the hypothesis of the next one, is it? Yeah. So what can I conclude from this? How can I connect these? If a whole number ends in 0, then, okay, it's divisible by 10, a whole number is divisible by 10. That's not necessary, okay? I can instead connect the first with the last one. Then it is divisible by 5. Okay, now for the last one, we're going to kind of use both of them together, okay? So if we can, we're going to use the law of detachment and the law of syllogism to make conclusions. If it's not possible to make any conclusion whatsoever, we'll have to explain why. So number 7 says, if you live in Cincinnati, then you live in Ohio. If you live in Ohio, then you live in the United States. Ken lives in Cincinnati. Now that last sentence is my given. We'll come back to that. Let's look at my statements. My 2 statements. If you live in Cincinnati, then you live in Ohio. If you live in Ohio, then you live in the United States. Can I draw something from that? What can I take from that? If you live in Cincinnati, those are the same, so you can connect it to, then you live in the United States, okay? So that's the statement I'm thinking of. That's the law of syllogism, okay? Now we're actually going to use the law of detachment to further help me get my solution. So if Ken lives in Cincinnati, well, we just figured out, well, if you live in Cincinnati, you live in the United States. So if Ken lives in Cincinnati, what do we know? Yeah. Ken lives in the United States. Okay, and then last one. If you play basketball, then you are an athlete. If you play softball, then you are an athlete. Because if you play softball. So I guess first thing we need to check and see if I can use the law of syllogism. Can I connect those 2 statements? I don't think so, right? Why can't you connect them? Yeah, they have the same conclusion. It's like an if A then B, and if C then B. Okay, I can't connect those. So I can't say, well, if you play basketball, then you play softball. I can't connect those. But I can draw some conclusion from this. Because if Miss B plays softball, then... Thanks! That's so nice of you guys to say. I do play softball and I am an athlete. I'm just kidding. Okay, so yeah, if Miss B plays softball, then she is an athlete. Good. Okay, pretty easy today. Okay, let's get both of these glued in. That first one is going to get glued into page 25. This is section 2.4, and we're talking about deductive reasoning. Deductive reasoning.